seems nobody has an idea why we use PLCs or microcontrollers, but you should not worry. We are going by the end of the session, you'll be able to know why we use PLCs or microcontrollers. So why PLC is used over microcontrollers? This is usually an examinable question. You can be told to compare the two, or why, or this applies when you're told to discuss the advantages and the advantages of PLCs over other types of controlling devices. So first of all, you might need to ask yourself what is a microcontroller. Though it's not part of this unit, but I can give you a description. Microcontroller, you all know that is a compact system, a compact integrated circuit system that is designed to manage devices that consist a control system. That is just a brief description of that. And these devices, they are embedded devices that have processor, memory, and input-output control in one unit. So that is what we call a microcontroller. We have said, yeah, there it is. A compact integrated circuit, a compact IC designed to manage devices that consist a control system. They are embedded devices that have processor, memory, and input-output control in one unit. These microcontrollers are usually very expensive and can also perform similar processing tasks that resemble the ones in industry. So let us look at the advantages of PLCs over the microcontrollers. So one of the advantages is that a PLC is user-friendly. Number one, user-friendly. User-friendly. So this is perhaps one of the top reasons why most people would prefer a PLC over any other controller, that is the microcontroller. Anyone can easily learn the basics of the PLC and immediately start using it, and because it has a very short learning curve. This means that the time that it will take you in getting from step 0 to maybe more complex functions of a PLC is more shorter as compared when you're trying to learn the operation, how to operate and run a microcontroller. You just have to know the basics of the PLCs, and that's why you're doing this course. You get the basics, and then you know how it works, different devices, how to program them, and then and also how to connect them, and then you'll be ready to be able to run and operate a PLC. There are a lot of things that you should be aware of, whether they should be grounded or not, and where they should be connected or shorted to, and this will not be a problem if you had the PLC programmer. So that is one of the advantages of using PLC or microcontrollers. Even though the disadvantage of PLC is the limited resources about it, they are available on the internet, because you realize this is a PLC is like an innovation in the field that therefore there is limited information about the PLCs. But the companies that make these PLCs, they usually make customer get everything that they need. Once you buy a logic controlling device, then it comes with the manual, and you also have with that manual you'll be able to have that information on how to run and program, and also know the basics of the PLC. We have the detailed instructions on how to use the product, and this makes the customer to be able to use it to its full potential immediately. So you don't need a lot of information for you to be able to run and operate a PLC. Even when you buy the input devices for the logic controllers, the user manuals also are available. And this is one of the advantages of this proprietary device. So that is one of the advantages of using PLCs over microcontrollers. That is the user-friendly. Advantage number two is the ease of programming. It is very it's very easy for you to be able to learn how to program a PLC. This should be under the user-friendly heading, but you can use it as a different point because it was the user-friendly. It has a lot of you can split the user-friendly advantage into a lot of things, but let us use ease of programming as a separate point. So it is usually a great bonus because it would not take a lot of time for them to be able to understand the program that is uploaded to the PLC. In the microcontrollers case, some already use the flowcharts in programming, and but they usually are programmed using lower level programming languages for those guys who are doing computers, such as the use of C and other types of programming languages. Then another advantage is the modular design. Modular design. We have already talked about the classification of how you classify PLCs, and we say the two major classification. You said is the compact, and the other one is the modular design. The modular design is you said it incorporates the use of where you can customize your PLC to suit the user needs, of which is an advantage over the microcontrollers. Microcontrollers, they don't have that modular design whereby you customize based on what you have. The modular PLC uh, has the many types of modules that you can just plug and you run. You call it plug and play in order to start using your system. Expanding your system will only take a very short amount of installation time because the modules are just basically plugged in and to the rack amount of the to rack mount the PLC. And these modules usually include the memory. We say you can expand the memory and also the input output points and also the communication part of the PLC. This design allows the PLC to be scalable and therefore allows your system to expand along with the business. So you can start your business having a limited number of input-output units, and as your business expands, then you also expand your PLC, bearing in mind that the PLC has that modular design. So you just customize, you buy more the output devices and input devices, and then you plug them into your controlling your PLC system, and you are good to go. And not only could you be able to add components that are able to easily upgrade your system's capacity, but because of the modular design, you're also relieved of some troubleshooting problems. We discussed that when we were talking about the advantages of the modular design as compared to the fixed designs, such as the microcontrollers. And when the fault happens in a PLC system that has the modular PLC design, you are easily able to identify which modules is causing the problem, and you're able to replace it by a spare one, and you are able to start your operations immediately. We also say the modular design does not eliminate that problem of having downtimes. So the faulty module will be sent to the service center for repair, and you have the other one for backup running already. So that is an advantage of having PLCs, the modular design, as compared to the microcontroller. Advantage number four. Advantage number four is the safety of the systems. So the safety PLCs have integrated safety functions called redundancies, and is so I've said it's called the redundancies, and this one is achieved that they accomplish two objectives. One, the maximum uptime. This ensures there is zero failure. Maximum uptime. So there they are, the maximum uptime. That is to ensure there is zero failure, and also in an event of failure, it is safely to do so. So that is an advantage of the PLC. So not only that, but even normal PLCs already have the safety systems which make the safety of the PLC even safer. Diagnostic features are installed in all PLC devices such that before the system even starts, it detects the errors that the operator or programmer may have overlooked in the PLC commission. So before you have your PLC system running, the system itself will be able to run through the diagnostic system, and it can identify if there is any fault pertaining the system. So before it runs, it is able to detect the faults, and you're able to have your system run in a safe operation mode. So you correct the the problem, and then you have your system running. So that's why I'm saying it ensures there is maximum uptime, and in the event of failure, it is safe to do the correction. Another advantage of the PLCs is their robustness. Advantage number 5, robustness. What do we mean by that? The microcontrollers will not be able to handle the extreme conditions in the work areas of an industry. And when we are talking about the advantages of PLCs over the relays, we said the PLCs replace the relays. We said that the PLCs, they are able to withstand harsh conditions, the extreme conditions that are experienced in an industry setting. So the microcontrollers are not able to withstand those extreme conditions because they come unshielded, and they are subject to electromagnetic interferences because of the radio waves that are present everywhere, and therefore they cause a disturbance in the unit via the electromagnetic induction or the electrostatic on the coupling or the conduction problems that arises in an industry setting. So the PLCs, they are able to withstand those harsh conditions. That's why we're saying they are robust. The power fluctuations may also easily destroy your microcontrollers, but in PLCs, these are not even a problem because they are immune to noise, and they can easily handle the high temperatures in an industrial setting, along with the power fluctuations through regulations. So the PLCs, they're able to withstand that, the noises and the other interferences, and also power fluctuations. Especially in Kenya, every now and then we have power fluctuations, and the PLCs is able to withstand that as compared to the microcontroller, which cannot withstand that. When you have power fluctuating, then there is that high chance that your microcontroller will burn out. Another advantage of PLCs over the microcontrollers is the maintenance. It is easier to do maintenance of the PLC, and they usually require little to very little maintenance because they are robust. And any maintenance electrician that may be assigned to the PLC system can easily check the whole system because the connections are just easier, and the program is highly readable, and it can be standardized. So maintenance of the PLCs is easier to do. Advantage number 7 of the PLCs is the historical inertia. What is that? The PLCs are systems that have already proved themselves throughout the years of application and development. It is solved the major problem of control using the relays, solved the major problems of the control using the relays. I've already done that in the earlier part, and it's just continued to develop to suit companies that develop with a wide number of controlled devices. So nowadays, the PLCs can even be networked using peripherals such as the Ethernet and other communication devices, and this makes a more complex system out of a basic PLC setup. And also, because the PLC was used since a very long time ago, companies are less likely to migrate to a microcontroller-based setup when the spares that have been already designed, when there are spares that have already been designed for the PLC system. Even so, new equipment for the PLC is still compatible with the old ones that were manufactured years ago. So even if you buy a new equipment to plug into your PLC system, it is compatible with the new ones. And this makes PLC even more cost efficient in the long run than the microcontrollers. So that is the historical aspect of the PLCs over the microcontrollers. And then the other advantage, front costs are less important. The upfront cost. So for companies that are making millions and millions of shillings every year, buying microcontrollers, a PLC control system is more expensive than buying microcontroller-based ones, and would still be likely the best option. Why is that so? This is because even though the initial costs are high of buying a PLC system of a microcontroller, so even though the initial higher cost, the maintenance costs we have said they're extremely low, and these systems are usually digitally designed that they're able to alert you before before that fault happens. So it goes back again to the previous mentioned reason. The PLC is easy to learn, so it does not need a programming expert, and it is robust. And there is that the compatibility issues are long gone as compared to the microcontrollers. And then we also talked about the safety mechanisms that are present. Just everything that a company wants for a device that lasts is already in the PLC. So though the initial cost is high as compared to the microcontrollers, but the other advantages outweighs just that one disadvantage of cost. So microcontrollers are cheaper, yes, but their qualities are just not the ones that the companies are looking for an industrial setting. So it's really the matter of quantity over quality, with high productivity for them, and the people should try to apply this in their lives too. The case of quantity over quality. In the long run, the PLC would produce less downtime than the microcontroller-based ones, and therefore generating more assets to the company with a lower maintenance cost. And the last advantage of the PLCs over microcontrollers is the standardization. Somebody is saying, I repeat, point number 7. This is patience. I see, can't see. I don't know if you can see it now. Able to see now? So maybe I can just go through these points for those who can't see. You said one advantage is that they are user friendly. So their interface is user friendly as compared to microcontrollers. Then there is that the ease of programming, and also the modular design. We talked about this when we were discussing the types of PLCs, the modular design. And then we talked about the safety systems, the safety of the whole system. Then after that, we talked about the robustness as point number 5. We said that the PLCs are able to withstand harsh conditions in an industrial setting. So they are able to, such harsh conditions are such examples are the electromagnetic waves, the radio waves, the noise, and the extreme high temperatures. So that is the point number 5, robustness. Point number 6, we said maintenance. We said PLCs, they require very low maintenance because they are very robust. And the system itself is able to inform you earlier prior to the fault that you may need to replace this component of that. Then point number 7, we have talked about the historical inertia, whereby we say that the PLC systems have already proved themselves throughout the year of their existence, and we say they solve that problems of using relays in the control system, and they have continued to develop to suit companies that deal with a wider number of control devices. So because the PLCs have been used for a long time, companies are less likely to migrate to the microcontroller based setup, because even when the spares that are designed for the PLC systems that were manufactured years ago, they are bought. When you buy a new repair equipment, it comes and it is able to be compatible with the new type of PLCs. Is the explanation of the historical inertia. I don't know if it's okay now. Patience, historical inertia, and then you have said point number 8, the upfront cost. That is the cost. So under this we said though the PLCs are more costly, the initial cost is high as compared to microcontroller based systems. So the initial cost is high, but because these systems they require little maintenance, then that cost itself and plus other number of advantages we've seen that like the robustness, then that initial cost is outweighed by the other advantages. Because if you buy a microcontroller which is cheaper, but it does not come with the advantages that we've talked about that comes along with the PLC. So we're talking about the last point, that is the standardization. Yeah, patience is okay now. So the standardization as an advantage of PLCs over microcontrollers. Standardization, that is. So standardization, this entails that in companies that they want more standardization rather than high customization approach to control system design, you realize that you want your products to be standardized instead of having to customize each and every product that you design. Therefore, in the PLC systems, this eliminates the confusion in troubleshooting or in programming, especially when there are different people involved in the same task. And as like we have mentioned earlier, companies let people check the PLCs in a concurrent fashion. This means that a standard must be followed and complied to strictly to avoid confusion, which generally causes large problems in the long run. So, standardization. PLC allows your products to be standardized instead of customizing everything. And therefore, we have said there is a standard method that must be followed and complied to strictly. And this eliminates that confusion, which generally causes problems in the long run. So those are the 9 advantages of PLCs over microcontrollers. I don't know if anybody has a question. Any questions so far? You're now unmuted if you have a question before we summarize the class. If you don't have questions, maybe I'll ask you myself.
You are now unmuted.
Yes, Wanjiko, you have a question?
Yeah, I wanted to ask if you are asked the advantages of PLCs over the relay control, can you give the same points?
The advantages of PLCs over relays.
Yeah.
Uh, you don't necessarily have to give the same point, but beside the PLCs, there is the relays in the market. So why is that so? So for you to answer that question, you ask yourself what are the specific advantages of this PLC system over the relays. And some of the advantages of the PLC system over the relays, we said is that such as the PLCs, like the ones that we have gone through here, the cost. So the initial cost might be high, but the maintenance cost outweighs the initial cost. We talked about the compatibility, also the thing advantages. Another advantages such as the robustness. The relays could not handle extreme conditions in an industry, such as the relays. They are mechanical devices, so they could be interfered with things like the electromagnetic interferences and the radio waves. But for the PLC, it's able to withstand that. And another advantage is maybe like the safety of the whole system. When you talked about safety, we said that for the relay, when you want to do some corrections, maybe you are experiencing a fault. For the relay, it's not as safe to do that correction, the fault diagnosis, as compared to the PLC, because normally the PLCs, they already have the safety systems incorporated in the whole programming, so it is easier and it is more safe. And also the uptime and downtime. For the PLCs, we have said they have little to less to no downtimes because they are separated, especially the modular designs. Each, like the power supply, the communication, the input output system, they are all parts by themselves. So the uptime is always there. But for the relays, if there is you want to repair something, then the whole system must experience the downtime. You do your correction, and then you have your system up and running. So those are some of the advantages of PLCs over the relays. Is that okay, Sanjit?
Yeah.
Yeah. Any other question? Maybe you can hear from Patience.
No, I'm okay. I'm okay.
If you are okay, you don't have a question?
Yeah, I don't have a question.
If you don't have one, I have one for you. Is that okay?
Okay.
So we said, what are the two major categories? How do you categorize? What are the two major broad categories of PLCs with regard to their design?
We have the modular type.
Yes,
To the design or types.
The two, I'm saying the two major categories. How you can categorize PLCs? The two major.
The
types.
modular type.
Huh?
The modular type and yeah.
Or fixed.
Yes.
So out of the two, which one is more advantageous?
The modular type.
Okay, that's very okay.
Yeah.
And maybe the last person, let me see who can talk to us. Combo. Yes, Mr. Combo. You have a question?
I have nothing, mister. I've got no question.
You have nothing or you have no question?
I've got no question.
Okay, that's okay. So if there is no question, maybe you can summarize, not summarize, but end the class there. Is that okay with everyone?
Okay.
So meanwhile, I'll be uploading.
Excuse me, sir. Kindly share the notes that we've just gone through.
These notes.
Yeah.
Okay, I will share, but I will restrict them. The only people who are attending live session. So inform your class that.
Sorry?
I said I'll share the notes.
Yeah.
But they will be restricted to only where you'll be able to access them.
Okay.
Yeah. So I believe there is no any other question. There is no any other question. You can we take the register and then we call it a day. So have a good afternoon, all of you.
Okay, so have a good evening.
You are now unmuted.
Thank you, and you too.